In this video, we're going to talk about integral exponents, or in other words, we can say integer exponents. All right, and remember your integers are your natural numbers or your whole numbers and their opposites. And so we're just going to look at whole number exponents. In order for us to do that, we're going to review rules of exponents. And so in each of these cases, we're going to assume that A and B are non-zero real numbers, and M and N are going to be our positive integer exponents. There are several rules here. Some of them are more definitional, and some come from just patterns that we notice in mathematical expressions. So we have our product rule that says, oh, if I have a to the m times a to the n, remember when we have exponential expressions, a is the base. So when the bases are the same and there's a product understood to be between those bases raised to their exponents, then you add your exponents together. So something like 2 squared times 2 to the 4th power, we can simplify that since the 2 is your base, that's the same. That's 2 to the 6th power. You just add the 2 and add the 4, right? And the reason that this happens, I'll do this for this example. 2 squared is 2 times 2, and 2 to the 4th power is 2 times 2 times 2 times 2. 2 multiplied 4 times, right? And so if I add all those exponents together, that's 2 multiplied 6 times, right? A similar rule is with the quotient rule. If you have bases that are the same, what you can do to simplify that expression is to subtract your exponents. And so if I had 2 to the 4th divided by a 2 to the 3rd power, well, I can just write that as 2 to the 1st power, because 2 to the 1st power is that 4 minus 3 is 1. And again, that works because of our properties of numbers, right? We can cancel all of our common factors since that's all multiplication. And so we'll be left with 2 to the 1st power. Instead of writing all this out, we can use this shortcut to subtract those exponents. The power of a product rule: if I have two bases that are different, or two numbers that are in a product, or two factors, raised to a single exponent, and there's a product inside of that parenthesis, then I can simplify this by applying that exponent to both of those factors that are in that parenthesis there. So that simplifies to a to the m times b to the m. Similar thing happens when there's division. Note here that this does not apply to addition and subtraction. It only applies to multiplication and division. So if I have something like 2 times 3 to the 2nd power, right? Now we know that that's 36, right? 2 times 3 is 6, and if I square 6, I get 36, right? Or another way to do it using this rule, even though we really don't usually do this, is you can say that this is 2 squared times 3 squared. 2 squared is 4, 3 squared is 9, and we know that 4 times 9 is also 36, right? That's an application of that rule. A similar rule with the power of a product. If there's a division, power of a quotient rule, we have a division here raised to a single exponent, then you can take those exponents and apply it separately to the numerator and the denominator. We have a power of a power rule where we have a base to an exponent, and then that entire expression is raised to another exponent. So you're raising a power to another power. Then you just multiply those exponents together. So if I have something like 2 squared, right? Well, we know that 2 squared is 4 and 4 squared is 16. So we know that this expression equals 16. But one way that we can do this without doing all that squaring, right? It's easy with this little number here. But what we can do is, we can just multiply those exponents. So that'll be 2 to the 4th power, and that's 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, right? So we can come here and just apply the exponent versus taking it in steps, right? This is more of a definitional rule. Actually, there's a reciprocal definition. I hope you guys can see that, okay? There's a definition, reciprocal. A to the negative 1st power is 1 over a, all right? These are identically the same. It's more of a definition here, all right? So when you raise something to the negative 1st power, that's equivalent to doing the reciprocal or flipping the fraction, right? And so if we have a to the negative n power, where we could rewrite that without a negative exponent by doing its reciprocal, All right, and so this would be 1 over a to the n. And so if I have something like 2 to the negative third power, this can simplify to 1 over 2 to the third power, and we can figure out that 2 to the third power is 8, and that's how we simplify that. This rule can also be applied when you have a quotient or a fraction raised to a negative exponent. And what I did here is I wrote this down in steps. I have a over b to the negative m power. Remember, we have this power of a power rule. And so you could write this as a over b to the negative first power, and then that to the nth power, right? And so if I take care of that negative first, that means I do the reciprocal rule, which we have over here, which means you do the reciprocal. The reciprocal means to put that quantity over under 1, all right? That's equivalent to doing a fraction or taking the reciprocal. And so that means I'll have, if I apply this -1 as the exponent here, I get b over a to the nth power, which I have here. And then if I look at this power of a quotient rule here, I can apply that m as the exponent on both the numerator and the denominator. And last but not least, we have a zero exponent rule. Anything to the 0 power equals 1 as long as that thing does not equal 0. All right. So this will be a review of your rules of exponents. Let's apply this to a few examples here. It says evaluate each expression without using a calculator. And so here I have -1/3 to the -4th power. There are a couple of things that I want to talk about here that I'm probably going to take a little more time than you actually need, but I definitely want to go over it. If you look at this, this is a -1/3. Now, you don't have to think of this way, but this is actually a -1 times a 1/3, all right? Now, you don't have to think of it this way, but you can, and that's raised to the -4th power. And so when you think of it this way, you can apply that 4th power because that's a product there. That -4 is the exponent to the -1, and you can apply it as the exponent to the 1/3, all right? The reason why I'm doing this is because I want you to be aware of what happens to this negative here. Now, the reciprocal of -1 is -1, right? I put it over 1, that's the reciprocal. And 1 divided by -1 is a -1, so it is its own reciprocal. So if I apply that negative to that, that's going to just be a -1 to the 4th power. Where here, if I apply that negative exponent to the 1/3, I get 3 as the reciprocal of 1/3 to the 4th power. Now, when I multiply a value that, whether it's positive or negative, an even number of times, whatever the number is, it's always going to be a positive result. So that part is just 1. And then here I have 3 to the 4th power, which is 3 times 3, which is 9 times 3, which is 27 times 3, which is 81. So I get 81. Okay. Now you don't have to do all of this. What some people realize is that, oh, I'm going to show you an alternative here. So let's come over here. People do the reciprocal first of this whole expression. So let's do this here. So if I do the reciprocal of -1/3, I'm going to get a -3 to the 4th power. And when I multiply a -3 4 times, a negative times a negative times a negative times a negative is a positive, and 3 times 3 times 3 times 3 is 81, right? So I get a positive 81. You don't have to go through all of this. I just wanted to show you an alternative way so that you don't get confused with these negatives, all right? Let's go to part B. I have b to the -4th power squared minus a -b to the -2nd power to the 4th power. Wow, that's a lot. All right, so if I want to simplify this, right, I have b to the -4th power squared. What I'm going to do is notice that I have a power to a power. When we have a power to a power, we multiply those exponents. And so that becomes a b to the -8th power. Let's go to this parenthesis here after the subtraction. Notice here, now I'm not going to do all this stuff that I did here with that, right? I'm going to do it this way. This is a 4 as my exponent, and when I multiply a positive or a negative number an even number of times, I'm going to get the positive result. Now, if that was a 3 there or a 5, that was an odd exponent, I do something different. So I know that when I raise this to the 4th power, I'm going to get a positive here. So I'm not going to write a negative here. Okay, so it's like that -1 is taken care of. I'm going to go to this here. That's a b to the -2nd power raised to the 4th power. A power to a power, you multiply your exponents, so that'll be a b to the negative 8. Okay, so I get b to the negative 8 minus b to the negative 8. We get 0 there. All right, let's go to part C here. I have this expression, 2x cubed y to the negative second times 1/4 x to the negative fourth y to the negative second. All of that's raised to the negative 2 exponent. What I'm going to do is I'm going to take this step by step. All right, I have a product here within this parenthesis, or these brackets. Here I have a square bracket. It doesn't mean anything special. It's just a grouping symbol. All right. What I want to do is I want to first apply, this is how I'm going to do this. This is not the only way you can do this. I'm going to apply this negative exponent to the two things that are multiplied here. So I get 2x cubed y to the negative second to the negative second power times a 1/4 x to the negative fourth y to the negative second to the negative second power. Notice there's multiplication all up in each of these parentheses, which means I can apply that negative 2 exponent to every term inside the parentheses. So that's going to be a 2 to the negative 2, x cubed to the negative 2, y to the negative 2 to the negative 2, right? Similarly, in this fraction here, or this set of parentheses here, negative 2, right? Now, this means to do the reciprocal because that's a negative. So I have a 1/2 squared. Here, a power to a power, we multiply the exponent. So the x to the negative 6th, power to a power, y to the 4th. Here, I do the reciprocal. So that's going to be a 4 squared. I'm doing that in steps. You don't have to do this in steps. You already know that's 16. That's fine. That's the 8. That's a y to the 4th, right? So a 2 squared is a 1/4. And that's the 16. Now what I'm going to do here is I know that 1/4 times 16, that's 16 divided by 4, that's a 4. I have here an x to the negative 6 and an x to the 8th. I add those exponents together because that's a product rule. Negative 6 plus 8 is a x squared. Here I have a y to the 4th times a y to the 4th. I get y to the 4 plus 4 are 8th.